I'm Helena Caudron, and I've been working for SEICO as a Senior Research and Development Engineer for 6 years, alongside my manager Richard Beasley and colleague Christian Farrier, who is the Lead Electrical Engineer. SEICO is based in Hanover, Germany, and was acquired by Exheat Group in 2019, who has offices and factories across the globe, including the United Kingdom, Singapore and India. SEICO specialise in an array of service and products to provide thermal solutions for industrial processes and projects all over the world. With a specialism in hazardous area heating and control solutions, we offer both standard and bespoke electrical heaters for major projects across the globe. Some of the heaters that SEICO provide are duct heating, immersion heating and process heating, as well as control systems for each type. SEICO's role in the project is to provide electrical heaters to heat the molten salts at 3 different stages of the process and to transform excess electricity from the grid or excess electricity from renewable sources into stored heat. The most challenging heater is the one that is integrated directly into the molten salt tank. Challenges arise from the corrosive nature of the molten salts and the high temperatures required. Careful material selection and clever heater control will ensure that the heater will work seamlessly with the molten salts. The 2 main parameters that the electric heater is concerned about is the temperature and the flow rate of the molten salts. For the temperature, the heater must ensure that all metal work is at least 290 degrees before the salts can be released into the vessel. To achieve this, the heater has a preheat mode, which is controlled by SEICO's control panel. The control panel also controls the heat tracing which is wrapped around the vessel. Once the molten salts are in the vessel, the control panel controls the power output of the heater to ensure that the salts achieve 600 degrees without risking the integrity of the heater. For the flow rate, the heater must be designed with carefully placed flow baffles to optimise the direction of the flow of the molten salts from the input nozzle to the output nozzle. SEICO are providing 3 electric heaters, each with their own requirement. The first heater heats the molten salts from room temperature to 330 degrees in a tank that is fully insulated to minimise thermal losses. The heaters have thermostatic control to ensure that the required temperature is achieved. The heating elements are inserted into metal tubes to ensure that the salt does not stick to the elements, as well as avoiding any molten salts leaking out of the vessel. The second heater is an inline heater within the PCM tank, which again has thermostatic control and is placed in metal tubes. This ensures that the salts remain at constant temperature and do not stick to the heating elements' metalwork. The third heater is in direct contact with the molten salts. The heater has several thermocouples within the molten salt tank that measures the temperature and feeds back to the thermostatic controller. This keeps the salt stable when needed and also allows for a smooth charge and discharge of the salts. It also reduces thermal losses by working with the heat tracing which is wrapped around the vessel, which is also controlled by SEICO's control panel.